I, Mrs. Prashuna Mukherjee, welcome you back once again for the chemistry class. Chemistry class, in the sense, I'm just going to clear up certain confusions and I'll clear up certain sort of difficulties in your chemistry subject. Now, today, what I'm going to speak is that I'm going to speak on the types of chemical reactions because we study it from a lower class, and then I'll talk a little bit about writing chemical observations. Okay. So this is applicable for classes from classes 6 to 10 only. But 6 chemical reactions, you don't have a wide range. 7 onwards, we learn chemical reactions, types of chemical reactions. So chemical reactions, generally the main 4 basic parts which we have, one is called combination reaction, one is displacement reaction, one is decomposition reaction, and the other one you have, though you don't have redox, redox is only starting from class 8, 9 onwards, and you're having double decomposition reaction. So I will not discuss now redox reaction because it is applicable for classes 8 to a certain extent and 9. Now, since I'm thinking of the basic type of chemical reactions, I'll just tell you about the different types of the chemical reactions. I'm going to talk about the types of chemical reaction. First is combination reaction. I'll just give you in short the gist that combination reaction means there will be two reactants, single product. If it is decomposition reaction, it is a single reactant which breaks up, decompose means breaking up, into 2 or 3 products. Now, decomposition reaction occurs by presence of heat, by passing electricity, and sometimes also in presence of light. So as per what we use, the A means cause, in that case we name it as thermal decomposition reaction, we name it as photochemical decomposition reaction, we name it as electrochemical decomposition. Now here I'm going to just clear up that many people, many students get confused. What's the difference between thermal decomposition and thermal dissociation reaction? Thermal decomposition reaction means breaking up of a reactant into 2 or more products, and it is a one-way reaction, irreversible reaction. If it is thermal dissociation, it is a reversible reaction. That means, giving an example for thermal dissociation reaction is that ammonium chloride, on heating, it decomposes to form ammonia and hydrogen chloride, and again you get back ammonium chloride because ammonium chloride is a sublimable solid. So you find that when we are heating ammonium chloride in a test tube, you find on the cooler ends of the test tube, on the upper parts of the test tube, we get the sublimate of ammonium chloride. So that is a basic difference between thermal decomposition and thermal dissociation. Thermal decomposition, once again I repeat, it is a irreversible reaction, and for thermal dissociation it is a reversible reaction. Now coming to displacement reaction. Displace means what? Removing one and taking the place of that one. So here displacement reaction means one element will be displacing another element from a compound, and it will take the place of that element. Now, which element can displace? An element which is more reactive than the other one, which is getting displaced. Okay, I'll just give you an example. Suppose I take zinc and copper. Okay, I take zinc granules and I take copper sulfate solution. So the reaction is, reactants are Zn and CuSO4. So Zn plus CuSO4 gives us ZnSO4 and Cu. So the reactants are metallic zinc, copper sulfate, and the products are zinc sulfate and copper. So what we find in this reaction is that zinc is displacing copper from copper sulfate. And why it has been able to do so? Because zinc is more reactive metal than copper. Here I should have discussed about metal activity series, but we don't have so much amount of time. In the metal activity series, you already know that metals are arranged in decreasing order of their reactivity. So the metal which is on top of the series is more reactive than the element or the metal which is lower down in the series. So a metal on top of on the higher part of the metal activity series will be able to displace an element or a metal which is lower down in the metal activity series. Now I come to double decomposition reaction. Now double decomposition reaction says there will be two reactants and there will be two products. Now double decomposition reaction is classified into two types. One is neutralization reaction and the other one is precipitation reaction. Okay, so here what happens in double decomposition reaction, two reactants forms two products by exchanging their radicals. Now radical means what? Suppose I'll give an example. NaCl plus AgNO3. NaCl plus AgNO3. AgNO3, Ag is plus, NO3 is minus. For NaCl, Na is plus, Cl minus. So what happens? It is the positive radical of the first reactant which combines with the negative radical of the second reactant. Whereas the other product will be positive radical of the second reactant combines with the negative radical of the first reactant. So ultimately we get two products. So NaCl plus AgNO3, the products will be AgCl plus NaNO3. If you write it down in your copy, you will, means if when you write it down, you find how the interchange is taking place. Now, as I have said already, the double decomposition reaction is of two types. One is neutralization and the other one is precipitation reaction. Precipitation reaction means what? In that reaction, one of the product will be a precipitate. And if it is a neutralization reaction, it will be the reaction between an acid and a base to form salt and water. That is the criteria for neutralization reaction. Now, I'm not going to go in details about any more of the chemical reaction. I'll just give you a short hint of how to write chemical observations. Now, chemical observations are a common part of chemistry which you start from class 7 till class 10. It's a very common question that what you observe when a particular chemical reaction takes place. Here, why did I choose this topic is actually because I'm telling you because writing an observation is a confused one. Some of them don't know what is meant by observation. Observation means when a reaction is taking place, what are the changes going on in that? That means what are the changes you are able to see? That will be your observation. If there is a color change, suppose I have taken a blue color solution and after the reaction takes place, I'm getting a green color solution, that is my observation. If I see that when I'm giving a common example in your day-to-day life, suppose you drink cold drinks, soft drinks. When you open the soft drinks bottle, you find some bubbles coming up. So that is effervescence. So that is your observation, that what you observe when you are opening the cold drinks bottle or the soft drinks bottle. Next, I come to another one that at home you can see this, means in order to demonstrate observation, I'm telling this, you take some baking soda and you add vinegar. Vinegar is acetic acid, but vinegar we use in certain cooking, certain food preparation also. So when you add vinegar to baking soda, you find again that bubbles of gas are coming out. So that is your effervescence. Okay. So this effervescence is the observation which I am noticing when this particular reaction is taking place. So as I have mentioned, effervescence is one type of observation. If there is any color change occurring during the reaction taking place, that is your observation. If you find a gas is evolving which is having a color, that is your observation. If you find that a gas is evolved which is having no color but it is having a smell, then also you can write that this gas is evolved, a colorless gas is evolved, this is having a pungent smell or a choking smell. So that also is your observation. But if anyone writes that if you are given a chemical reaction and that particular student is writing that yes, when I am heating this, I get this and this other products. Giving a short example, suppose I am heating lead nitrate and the student answers, the question is given to the student that what will you observe when lead nitrate is heated? He or she answers that when lead nitrate is heated, I am getting lead monoxide, I am getting nitrogen dioxide and oxygen. So this is not your answer. Observation means what are the changes you are going to see when that particular reaction is going on. So in case of this answer, what will be the answer? When I am heating lead nitrate color is white. After the heating is completed, you find a yellow residue at the bottom of the test tube. We see the evolution of a reddish brown colored gas which is having a smell, an irritating smell. So these are the observations or the changes which have taken place when the reaction is occurring. So this is what you have to write. I'm going from lower classes to class 10 onwards. A very common question is, what will you observe when the particular reaction takes place? Please, my earnest request to all of you, don't write the names of the products or don't write the equation. That I have written the equation, this is my observation. The teacher is going to find out what is the observation. No, your observation is that if you want to write the equation, well and fine. But along with that, you have to mention what are the things which you observed changed when the reaction took place. Okay, I'll give you a short example. This one I said about carbon dioxide, that baking soda vinegar. This is a common experiment which is done in lower classes also. And for class 6, I'll just mention a little bit of this. That if you take an ice cube out from the fridge and you keep it in a tumbler or in a bowl or anything, after some time you find that the ice melts and changes to water. And where you have kept that ice, that outer surface of that container is showing water droplets. So this is also an observation. So we can write that when ice is brought out from the refrigerator, it melts to water and we find water droplets on the outer surface of the glass tumbler or the container where we have kept it. So these are, I'm giving examples. Why? Because it is applicable for a particular class. When I said about ice, it's only applicable for class 6. It's not that class 7, 8 onwards. You may have, but the things means how to understand, how to get an observation. That only I wanted to give an example. For higher classes, I said about lead nitrate heating. Another one I'll be giving one example. Suppose just now I'd given the example of displacement reaction. I have said that I have added metallic zinc to copper sulfate solution. We got zinc sulfate and copper. So this can also be in the part that what will you observe when zinc is added to copper sulfate solution? Your observation will be copper sulfate solution color is blue. When it changes to zinc sulfate, it becomes colorless. And who is displaced out? Copper metal. So copper metal color is reddish brown metal. So we will see reddish brown metal deposited in that colorless solution. So that is the observation. After writing this observation, you can write the equation as well. But only writing equation or only naming the products will not help you out. Okay, so be very careful when you are writing observation. Again, I repeat, these are the changes which will be observed by the student, or you will see that when you read the book you will find there are many reactions along below that the observations are given. Okay, you have to understand how to write an observation. Again, I repeat once again, since chemistry is a subject many of them feel it's a scaring one or what, I'll just suggest you how the way of studying chemistry is that make more of writing practice, means write more and make yourself perfect. Thank you.